Hi, it's Carly McAvoy. We're looking at quadratic equations. I'm talking about the discriminant in this video. So a quadratic equation is ax squared plus bx plus c equals 0, standard form. And then we have the quadratic formula, which is a way to figure out what x is in that equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is b squared minus 4ac. It's this little piece, this little expression that's under the radical. And using the discriminant alone, we can decide how many solutions we're going to get for an equation and the type of solutions that we're going to get. So we have four scenarios. The first scenario is that the discriminant is 0. So if I have something like this, negative 3, and my discriminant turns out to be 0, that is the b squared minus 4ac, turns out to be 0, then look what happens. I get negative 3 plus or minus 0 over 4. I just get one solution. One solution, and it's rational. That is, there's no radicals in it. So if you get a discriminant of 0, you're going to get one rational solution. Scenario number 2 is that you have a discriminant that's a positive perfect square. For instance, if I had negative 3 plus or minus the square root of 25. Well, what would that look like? That looks like negative 3 plus 5 over 4 and negative 3 minus 5 over 4. And that gives us 2/4 or 1/2, or negative 8 over 4 is negative 2. But it's two rational solutions. I don't have any radicals left because this came out to be a perfect rational number, 5. So if I have a perfect square under here, and it's positive 2, if I have a perfect square, I'm going to get two rational solutions. All right, scenario number 3 is that the discriminant is positive, but it's not a perfect square. So up here, I got square root of 25, which just became 5, and then I didn't have any irrationals left. But here, this is not something I can simplify because it's not a perfect square. So my answer is going to be negative 3 plus the square root of 15 over 4, negative 3 minus the square root of 15 over 4. I get two solutions, but they're irrational, which means they still have that radical in there. So the discriminant being a non-perfect square but positive tells me I'm going to get two solutions that are going to be irrational. The fourth scenario is I have a discriminant that's negative. That's going to give me two imaginary solutions because when you get a negative under your radical, that's going to cause that to become imaginary, and we're going to get I square root of 7, right, over 4. So if you ever get a negative under there as your discriminant, you know you've got two imaginary solutions. This is showing two solutions. So looking at three different equations here, I could find the discriminant of each of these, and by the discriminant, I wouldn't solve it, but by just using the discriminant, I could tell you, is it going to have one or two irrational, rational, imaginary, whatever solutions. So looking at the first one, b is 4, so 4 squared minus 4 times a, which is 1, times c, which is 1. Well, that's 16 minus 16 is 0. What does that tell me? Well, that tells me if my discriminant is 0, then I'm going to get one rational solution. So I know I'm going to get a rational solution, but I don't know what that answer is by the discriminant. It just tells me what to expect. Okay, for the second one, I have 1 as my b, so 1 squared minus 4 times a times c. That gives me 1 minus 80, or negative 79. Well, when I get a negative, I know right away I'm going to get two imaginary solutions. All right, and the last one I have, a negative 13 is my b, so negative 13 squared minus 4 times a, which is 1, times c, which is 7. 169 minus 28 is 144. Well, 144 is positive, but it's not a perfect square. Whoops, where am I pointing here? Right here. Discriminant is positive, but it's not a perfect square. Since it's not a perfect square, I'm going to be left with a radical in my answer. That's how I know that for 141 being the discriminant, I'm going to get 2 irrational solutions. So that's what we want you to do, is plug into that very simple formula, b squared minus 4ac, and then looking at the answer of that, tell which of these type of things is going to happen. The other one that I didn't work out was having 2 rational, and that is if you get a perfect square under there, then you get 2 rational solutions. All right, have a perfect day, and I'll see you next time.